Today we're going to discuss the topic of inverses and inverse functions. Now the definition of a function means that for each input we only have one output. So for each x value we have one y value. We can use the vertical test when given a graph to determine if a graph is indeed a function. When we find inverses, we also want to determine if they are functions. Before finding inverses, we can actually look at a graph of an original function and apply a horizontal line test to determine if its inverse is indeed a function. So look at the blue line. This is an original graph. Y is equal to f of x. If we want to determine if its inverse is a function, we perform the horizontal line test, which is the red line. If the horizontal line only touches the graph in one spot, then the inverse of the original function is also a function. So in summary, if we're given a graph and we want to determine if it's a function, we perform a vertical line test. If we're given a function and we want to determine if its inverse is also a function, we perform the horizontal line test. So we can determine if an inverse is a function, but how do we actually find the inverses? Here's a step-by-step process. Step 1, determine whether the function has an inverse by checking to see if it is a one-to-one using the horizontal line test. Then, in the equation for f of x, replace f of x with y, and then interchange x and y. Solve for y, and then replace it with our inverse notation. Finish by finding the domain and range. So I have a picture below. We're going to start with step 1. Here is our horizontal line test. We did horizontal lines at 2 different spots, and we passed each time. We are only touching the graph at one spot. So our function does have an inverse, as proven by the horizontal line test. The next step says, for the equation for f of x, replace f of x with y, and then interchange x and y. The next step says we need to isolate the y terms. So I'm going to multiply both sides by y plus 2. And I want to collect y's together on one side. So I'm going to subtract y from each side. And then I'm going to bring the 2x to the right-hand side. The purpose of doing this is I'm trying to isolate y. Now I have my y's on one side of the equation, so I can factor out y. I need to get y by itself. So I'm left with y is equal to negative 2x minus 1 all over x minus 1. The last step, or the third step, says replace y with the notation for the inverse. Now we need to finish by finding our domain. So let's look at the instruction. It says state any restriction on the domain of the inverse of f. So let's go find the restriction on our final answer. So x cannot equal 1. If x equals 1, then our denominator would be equal to 0, and the entire thing would be undefined. Going back to step 4, it says, then show that the domain of f is equal to the range of the inverse, and the range of f is equal to the domain of the inverse. So that sounds a little bit confusing. Think about what the inverse is. The inverse is where we swap x and y and then solve for y. If we're swapping x and y, that means that what we're doing is we're really swapping our domain and range as well. So we found the domain for the inverse. I'm going to actually write that in our proper notation. The range for our inverse is the same as the domain for the original function, meaning that if I can find the domain of the original function, I have the range of the inverse. So I go back to the original, and what is the value of x that makes that function undefined? If we plug in x is equal to -2, the denominator would be equal to 0, and the entire thing would be undefined. So that is our range of the inverse. So in summary, we have an original function. We can find its inverse by swapping x and y. That means that the domain of the original is the same as the range of the inverse, and the range of the original is the same as the domain of the inverse.